Alright, Assalamualaikum warahmatullahi wabarakatuh. This is the third part for chapter 2, okay, 2.3 representation for signed integers, okay. So, complementary representation. So, we normally represent signed integers by a plus or minus sign and a value. So, for example, we have a positive 16, a negative 4, negative 5, for example, and so on. Okay, so in computers, we cannot use a sign symbol. So it must be restricted to zeros and ones. Because machine language, we are talking about the binary system, so 0 and 1 only. So the representation of sign numbers for the machine language or for the binary, okay, we have sign and magnitude. The first representation is sign magnitude. The second one, we have one's complement. And the third one, we have two's complement. All right. This is how we represent our sign number to make sure that the machine can understand, the computer can understand. Okay. All right. So for the first representation, which is the sign and magnitude, okay. So the example is, for example, if we have positive 1, okay, it must be represented as 0, okay, start with 0, and the magnitude. So what we have here is when we said that we have sign and magnitude representation, this is actually represented by a sign bit, all right, and followed by the magnitude. Okay, so this is what we call as sign, okay, followed by the magnitude. All right, so 0, okay, sign 0 indicate that this is a positive number, okay, while if the sign is equal to 1, meaning that this is a negative number or a negative value. So this is sign followed by the magnitude. All right, so for this sign and magnitude representation, all right, the magnitude has the same value, all right, but then the difference is the sign. So if you have, for example, 0, 0, 0, 0, 0, 0, 0, 1, 0, this is actually a positive 2. So if you want to represent negative 2, you just need to change the sign bit into 1, all right? And then followed by the magnitude. So the magnitude is actually the same, 0, 0, 0, 0, 0, 1, 0. Okay, remember, sign magnitude representation, sign and magnitude representation. The only difference is the sign bit, okay? So this number must start with a sign bit. So sign bit is equal to 0, we know that it is a positive number. If the sign bit is equal to 1, we know that it is a negative number, okay? Okay. One's complement. Okay, for the one's complement, the numbers that begin with 0 are positive, we know that. And then the numbers that begin with 1 are negative. So what we need to do is, for one's complement means, we need to perform by changing every 0 to 1 and every 1 to 0. We do the inversion, okay? We do the inverse, all right? Or we do the flip, okay? So for example, for one's complement, okay, if you have a positive 1, we know that it is equal to 0, 0, 0, 0, 0, 0, 0, 0, 1. So when we need to convert into negative number by using one's complement, what we need to do is we just need to inverse the number. All right, we just need to inverse the number. So negative 1 equal to 1, 1, 1, 1, 1, 1, 1, 0. Okay. So what if we have 16, for example, okay, or we have 15, okay, the number is positive 15. So positive 15 is equal to how many bits it is? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 bits. So 8 bits means 1 byte. All right. So we have 0, 0, 0, 0, 1, 1, 1, 1. All right. This is positive 15. So if we need to convert into, if we want to know what is the negative 15 using one's complement, the answer would be, we need to flip, we need to inverse each of the bits. So the answer would be 1, 1, 1, 1, 0, 0, 0, 0. This is negative. 15. We just need to flip. We just need to inverse each bit. All right. So this is 1's complement. Okay. The third one. Okay. This one we need to do 2 steps. All right. So 2's complement means first step is we need to find the 1's complement. All right. And 2 complements means we add 1 to the result. Okay. So for example, 2's complement of positive 2 in binary. Okay, so first we need to know what is the positive 2. Okay, what is positive 2? So positive 2 equal to, this is the first one, this is the first step. We need to find the positive value. Okay, so positive 2 equal to 0, 0, 0, 0, 0, 0, 1, 0. This is 1 byte. Okay, 8 bits. Okay, base 2. All right, so what is negative 2? Okay, so first find the positive value for positive 2. Okay, and then what we need to do is we need to do 2's complement. So to do 2's complement, we need to find what is the 1's complement for that negative 2. All right, so 1's complement means, so 0, 0, 0, 0, 0, 0, 1, 0. We need to inverse each bit. Okay, we need to inverse each bit. So the answer would be 1, 1, 1, 1, 1, 1, 0, 1. So this is 1's complement. Okay. And then 2's complement means we need to add 1 to the result of 1's complement. So add 1 here. This is 2's complement. So this is the answer. So when you add, okay, to 1, so 1 plus 1, this is equal to 0, and then you have 1 carry here. So put the carry down here because 1 plus 0 equal to 1. So the rest turunkan saja. Okay. As usual, you do the addition, right? So you will get 1, 1, 1, 1, 1, 1, 1, 0. This is actually equal to negative 2. So remember, what is the step for 2's complement? First, you need to find the positive value, okay, in binary, usually 8 bits, okay. Why? Because this is equal to 1 byte. And then number 2, you need to find the 1's complement, all right. And then number 3, add 1, all right. Then you will get the answer for the negative value, all right. Okay, so for this one, for example, okay, for example, if we want to, we have one example here. So positive 14, we want to convert in what is the negative 14, okay, using 2's complement. Okay, what is negative 14 using 2's complement? All right, so let's do this. So positive 14 equal to 0, 0, 0, 0, 1, 1, 1, 0. This is positive 14. Okay. And then number 2, we need to inverse. Okay, we need to do 1's complement. So this is equal to 1, 1, 1, 1, 0, 0, 0, 1. Okay, because we inverse this into this. And then number 3, this is 1's complement. I would like to do that. Okay. Number 3, you need to add 1. Right? So 1 plus 1, 0, carry 1. So 1 here, 0, 0, 1, 1, 1, 1. So this is equal to negative 14. All right? That's all. Very easy. Okay. So that's all for 2.3. Okay, 2.3. Sign number representation. So we have 3 representation of sign numbers. The first one is sign magnitude. Number 2 is 1's complement, okay, where we need to inverse each bit. Number 3 is 2's complement. All right. So this is how we do for each of the representation. So I hope if you been given any question for this sign representation or sign numbers, you can do it. All right. So very simple. So I think that's all for 2.3. See you on the next video for 2.4. Okay, bye.